I invite Marisamynathan. He is going to speak on signalized intersection with crosswalk safer in India. Mr. Marisamynathan is a research scholar in the Department of Civil Engineering at IIT Mumbai, India. His doctoral research is on modeling pedestrian crossing behavior and level of service at signalized intersections. His research interest includes non-motorized transport safety, traffic analysis and design, and traffic operations and management. As a research scholar, he has more than 5 prestigious international journals and more than 10 significant international conference proceedings. Apart from that, he has an excellent consultancy experience and he has associated several projects in the area of traffic safety and management. Also, he is a member of Association of Transportation Professionals of Indian Origin, American Society of Civil Engineers, and Institute of Urban Transport India. Welcome to us.
Thank you, sir. Myself, Marisamy, research scholar. I am working with Dr. P. Vedagiri, Associate Professor from IIT Bombay. Today I am going to present part of my research work titled as A Signalized Intersection with the Crosswalk Safer in India, a study based on safety analysis using video data. So this is the outline of my presentation. Let's discuss one by one. Starting with the introductions. So intersections are the locations where pedestrian and vehicle sharing the same road space in the name of the crosswalk. As a transportation engineer, we provided various facilities to control and make them safe, comfortable and convenient crossing. Particularly for pedestrian, we provided the crosswalk marking, signage, refuge island or median width and exclusive pedestrian signal phase. And the second figure showing the typical four-arm signalized intersections with bidirectional pedestrian movement, which we captured in the Mumbai city. Now, the question is, signalized intersections already controlled by various facilities, then what is the need of the study related to the pedestrian safety? So let's discuss about the need of the study. Motivation. As per statistics, 16 people die on every hour in Indian roads, particularly 65% of accidents happen near the intersection. As per the statistic from Mumbai Traffic Police, 58% of the pedestrians' deaths were reported in Mumbai Central City during the period of the 2008 to 2012. So the fatalities rate and accidents rate for the pedestrian, particularly intersections, are high. So as a transportation engineer, our responsibility is to reduce the fatalities and accidents for the pedestrian as well as the vehicular traffic also. So this is the basic motivation of our study, and we raised the first questions: how to reduce the pedestrian fatalities and how to encourage the pedestrian and walking mode. And the solution of the question is to provide the safer facilities. Automatically, it may reduce the pedestrian accidents. Still, the question is rising: how to provide a safer pedestrian crosswalk at particular signalized intersection. And the solution of the question is to measure the existing operational conditions. Based on the conditions, we can provide the safer facilities. And the final question is how to estimate that existing operational condition. Various solutions are there, and one of the best solution is to develop the empirical model using the field data by considering various pedestrian traffic characteristics. And once we developed the empirical model, based on that model, we can analyze the existing conditions with respect to the safety. Once we understand the existing conditions, we can provide the safer facilities, or we can make any policies related to the pedestrian safety. Once we provide the safer facilities, it automatically reduces the accidents. So this is the motivation and the direction of our research work. Now, developing empirical model is not an easy task, particularly in Indian traffic conditions and users' behavior. So let's discuss the problem which we observed from Indian conditions. First, signal system. In India, most of the signalized intersections are operated by shared signal phase. That means during pedestrian green phases, pedestrian parallel throw movement and left-handing movements are allowed to cross the crosswalk. In that situation, there are highly possibilities for pedestrian interact with the free left-handing movement. Second is pedestrian facilities. In India, most of the signalized intersections are maintained by the improper facilities. There is no proper waiting area for pedestrian. Therefore, pedestrians are forced to waiting in the roadway. That kind of situations may lead to the accidents between the pedestrians and vehicle. And the third one is important behavior, pedestrian non-compliance behavior, and driver non-compliance behavior. So this kind of the non-compliance behaviors leads to the pedestrian vehicular interactions in the crosswalk during pedestrian non-green phases and pedestrian green phases. So these are the identified and observed crossing behavior of the pedestrian as well as the driver behavior, which we observed in Mumbai city. So the specific problem is modeling pedestrian vehicular interaction is a complex task due to the observation of the various behavior. Second, PET values for pedestrian is missing with respect to the Indian conditions, particularly signalized intersection, and it is difficult to evaluate the existing condition of pedestrian with respect to the safety. To solve this problem, we propose the three objectives, and our study first objective is to define the PET values for pedestrians and the severity level based on the collected video data. Second, to develop the cumulative logistic regression model which estimate the pedestrian severity level at signalized intersection. Finally, to evaluate the safety level by using the proposed PET value and proposed cumulative logistic regression. To achieve this objective, we reviewed a lot of literature. Based on that research gap, we formulated the study methodology, and this is the study framework. So let's discuss one by one. First, study locations. Mumbai is the most populous metropolitan city in India with a high rate of accidents and fatalities rate, particularly for pedestrian. In our initial study purpose, we selected 6 signalized intersections, and these are the basic description about our study location. All the locations are located at the central part of the Mumbai city, and all are the typical four-arm signalized intersection. All the signals are operated by the shared signal phase. And in our study purpose, we consider the bidirectional pedestrian flow. So these are the brief description about the study locations and data collections. So data were collected by conducting the videographic survey at selected 6 signalized intersection. 2 video camera were set up at each location, and this is the layout of the camera setup. And first figure showing that upstream to the downstream captures, and second figure showing that the pedestrian movement of the downstream to the upstream movements. Also, we used the stopwatch and measuring wheel to measure the geometric characteristic and signal time. And we conducted the morning and peak hour survey, and we collected the video data. Once done the video collection, we extracted the data by using the ABS video editor software, and software giving the 0.05 second accuracy level. And the data were extracted from video are 2 bases. First one is the pedestrian characteristics. It consists of pedestrian gender, age, back age, platoon, crossing speed of the pedestrian, crossing direction, and the compliance behavior of the pedestrian. So all these characters we extracted for the each pedestrian which observed from the video. Also, we extracted the traffic characteristics. For extracting the traffic characteristic, we divided the crosswalk into the 3 strips from curb to the median, and each strips we observed the behavior of the pedestrians and the vehicle. Also, we observed the interactions between the pedestrian and the vehicle. And the data consists of approaching vehicle type, whether car or two-wheeler, LCV or HCV. Also, we observed the approaching vehicle positions. That means the interacted vehicle came from the left-handing or right-handing or throw moment. And approaching vehicle positions, whether interactions happened in the first strip or second strip or third strip. So all the observations, all the data were extracted for the each pedestrians at each strips. Also, we collected the geometric characteristic from the 6 signalized intersection. Overall, we clearly observed 1,158 pedestrians, and all the pedestrian and geometric characteristics were extracted from all the 1,158 pedestrian. And this samples, we conducted the sample test. It gave the 95% confidence interval hypothesis test, and we utilized for the model development and model validation purpose. So next, PET values. So nowadays, the pedestrian severity level were evaluated with respect to the surrogate safety measure, and most of the studies utilized traffic conflict techniques and post-encroachment time. At present, our study, we are considering the PET value, and TCT we are including in the future research scope. And the PET is defined in our study is the time gap between the 2 road user arriving and leaving the same crossing area. Also, we defined the smaller PET value leads to the high probability of the interaction, and a larger PET leads to the lesser probability of the interactions. From our data, we observed 115 pedestrian vehicular interactions, and we defined the interactions in 3 categories. That means highly dangerous, dangerous or no conflict, and safe or conflict, safe or no conflict. So these 3 categories were we divided with respect to the severity of the pedestrian safety. And this is a small animations for BET definitions in our study. So first one is the time difference between the pedestrians and the vehicle arriving the crossing area, and second animation showing the difference between the vehicle and pedestrian. So all the data, all the PET's value we extracted for the observed pedestrians at each strips. Finally, we plotted the cumulative distributions graph. From that graph, we defining the PET values threshold for the each severity level. Also, we used the RAF method, and both the values we compared. In our study, PET values from CDF method is 5.5 second and the RAF method is 5.6 second. So both are close to match. Also, we compared our result with the other research study which conducted in IIT Madras, and they concluded the PET value is 5 seconds, which is close to our result. Also, the PET value for pedestrians with respect to the each vehicle type where we identified, and this is the result. From the table, we can understand that when the PET value is less than or equal to 2, the severity level is highly dangerous and 100% conflict will happen. When the value is between the 2 to 5.5, there is a dangerous zone and there is a possibilities of the pedestrian vehicular interactions in crosswalk. And finally, when the value is greater than 5.5, that is safe and there is no conflict between the pedestrians and the vehicle. So next, model development. So developing the model, initially we conducted the Pearson's correlation test in SPSS software at 95% confidence interval, and these are the identified significant factors. Using that significant factor, we developed the cumulative logistic regressions model, which can be useful to estimate the pedestrian severity level at particular signalized intersection. And this is the model outcome, and all the values are significant, and the valid value showing the 95% confidence interval. And the model is developed by using the 80% of the collected data. Using the 20% of the samples, we validate the model, and statistical performance evaluation were conducted. The MAP, RMS, R, and R square values are showing the accuracy level of the model. So now we developed the empirical model. So once we have a developed empirical model, we extracted the independent variables, we apply that value in the developed model. Based on that result, we can understand what is the conditions of the pedestrian at particular intersections with respect to the safety. So these are some selected findings. PET value of adult pedestrian is less than the other age group, and crossing speed play the significant role. Reductions are increment in the speeding would result in the interactions. Next, PET value for turning value are higher than the other movement vehicle. The lane of approaching vehicle close to the pedestrians lead to the lesser probability of the pedestrians interactions. So these are some selected findings from our studies. Then applications. So this section I am showing how to utilize our proposed PET values and developed severity index model. For that purpose, we selected another new signalized intersections in Chembur-Naka junction. So we extracted all the independent variables and we applied into the developed cumulative logistic regressions model, and the model showing that category 2. Category 2 means it is showing that severity level in dangerous zone, and there is a possibility of conflict between the pedestrian and the vehicle, no safe for pedestrian. So we need to make immediate remedial measure immediately. Otherwise, some policy making we have to provide for stopping the conflict between the pedestrians and vehicle. So this is the way of applications. So conclusions. So the video data were collected from the selected 6 signalized intersections. PET values were proposed for Indian conditions, and we developed the cumulative logistic regressions model to identify the severity level of the pedestrians at particular locations. Once we develop the model, we can understand and we can rank the crosswalk with respect to the severity level. Also, we can rank the variables. Based on that ranking, we can improve the existing operational conditions, which make pedestrians safe and comfortable convenience crossing at signalized intersection. So these are some selected applications and limitations of my study. Thank you.